Hi. Tonight let's look at one we did in the class tonight. This was the final question in tonight's class actually. Similar triangle. They don't give you too much here. We got a triangle here. They tell us this is 9. They tell us A to B is 12. All the way across is 12. This is 3. And they're just asking us for PQ. Doesn't seem like there's a whole lot to do here. A lot of information. Let's pause the video and see if we can solve it. Okay, so we're back and let's fill in what we have and see if we can make any kind of sense of this thing. You know, they put the 9 there for us, they put the 3. We know all of this is 12, so that we know is 12. I'm going to do this here. I'm just going to make this x and I'm going to make this, excuse me, 12 minus x, right? Because this plus this, the whole thing is going to be 12. When I see this, and I don't really have much going on in terms of side, now certainly somebody might say, well, if this is 9 and this is 12, like, can't you do the Pythagorean theorem and get that to be 15? I mean, that's one thing we could do. So I know this whole thing is 15, but the problem you kind of have here is that this thing is in parts, and it should sort of look like we have some similar triangles going on here, right? Similar triangles are just triangles where all the angles are equal, so the sides are therefore proportional. And the one thing I would take away from this problem, because certainly this problem is probably a little bit too hard for the SAT or the ACT, but the concept remains the same, and it's such that if you have a triangle here, the big triangle is always going to be proportional to the little one inside of it. Like, a lot of times kids want to say it's the big triangle is proportional like to this trapezoid or something, but you can't do that. It has to be triangle to triangle. So let's see if we can set up some proportions here and see if this takes us anywhere. Let's look at the big triangle. So I have a big height of 9, and I have a big base of 12, and I know that's got to be proportional. Let's look here at this little triangle. We got a problem here because we have an x, an unknown. I'm just going to label this a y. I don't typically like to do this, but just for illustrative purposes, it might make some sense. So the big height 9, big base 12, little height y, little base x. And let's clean that up and let's see if we can form some sort of relationship between x and y that we can use here. Right? So if I cross multiply, obviously I'm going to get that. And what I'm going to try to do is get something for x here, so I'm going to divide by 9, and I'll get 12 ninths y, which should reduce to 4/3 y. Right? So I know that x is equal to 4/3 y. And what I'm going to do now, in lieu of the x in this piece, and we're going to do the other triangle now, instead of x, I'm going to put 4/3 y there. And now what we should have is we can set up a proportion now with just one variable. So now I'm going to look at this other triangle here. So I'm going to say the big height 3 is to the big base, which is 12, right? As the little height y is to the little base, which is just 12 minus 4/3 y. All right, so now I have that. Now we could do the same thing. Because we only have y's in there, I should be able to get a number here. Let's see if it works. If I cross multiply there, right, I should get 12y. If I cross multiply that, that should be what, 3 times that whole quantity? So it's 3 times 12, that's 36, and then 3 times negative 4/3 y, which would just give me negative 4y. We should be able to clean this up. I'm going to add the 4y over. That's going to give me 16y is 36. If I divide both sides by 16, I'm going to get y is equal, I'll just go over here. Let's go up here. 36 over 16, which can reduce. I could probably take a 4 out of both of those, right? 9 over 4. There you go.